So welcome to 4Keys College of Science Education. I'm your host, Say Shungu. So in this video we want to talk about logic gates. So a lot of people have trouble illustrating the function of logic gates. Logic gates are one topic you wouldn't want to do just theory. You want to demonstrate and explain and discuss the real world applications of logic gates. So a lot of people find it difficult to demonstrate the function of logic gates, let alone describe the real world applications of these concepts. So what I've done is I've created an alternative for you if you're an A-level student or a teacher. Let's turn to page 21 of my module, which you can order. You can also contact us so that we come and train you how to do the coding. So there's an alternative to connecting those. There's a popular series of operational amplifiers, 4 of them, that are used to illustrate the function of these 4 logic gates that you're looking at. But if it's difficult for you to get the apparatus to do the connections and check if there are no errors, sometimes you connect your circuit and it still doesn't function because you have a loose connection or something is not right. If you do not have the equipment or the knowledge to connect the operational amplifiers, then there's an alternative. You can use the Arduino. The Arduino can simulate for you all the 4 gates. So this is what I want to illustrate and demonstrate in this video. So let's go straight into this. So the first gate here is the AND gate, whose truth table is here. So if you have both your inputs, so the circuit setup is described here. You need a push button A and a push button B, or switch A and switch B. So if I have 2 switches and both of them are off, then the overall result is that I'll have an off in my output. But if I have A off and B on, I still get no output. If I have my A on and B off, no output. If both of them are on, then I'm supposed to get an output. So you can think about the real world application of a situation where you need to have 2 inputs on at the same time for you to have an overall output to be on. You can think about such a situation in a project, and we can discuss this in the comments. Anyway, so let's go to the simulation and see if we are able to do this. So in my simulation, I required 2 push buttons, my Arduino and my LED light, and according to the code here, I'm supposed to put my switch A to pin number 2 and switch B pin number 3. So I've done that. And for me to illustrate my AND, what's the first gate here? Let's go back and check its AND gate. So for me to illustrate that, I would need now to connect my LED light to pin number 6. So let's connect the LED light to pin number 6. And now let me run the code and see whether we'll get the results that we have in our truth table. So this is the first condition. Let's assume it's been satisfied that I have both A and B off and I don't get a signal here, so it's off. But if one of them is on, A is on, B is off, I still get off. If I say B is on and A is off, I still get off. But if both of them are on, then I'm supposed to get a signal. So there it is. So it has satisfied my truth table. So this is illustrating the function of the AND gate. Let's move to the next type of gate, which is the OR gate. So OR gate, I'm supposed to put now my LED to pin number 7 according to this. And okay, so let's start. This is the first condition. Both switches A and B are off and I get no signal. The overall output is off. If one of them is on, A is on, B is off, I get an on. If B is on and A is off, I get an on. And if both of them are on, I get an on. So let's check whether this satisfies the truth table. So yes, if I had only one of the switches on, I got a signal. One of them on, got a signal. Both of them on, I get a signal. I get no signal if both of them are off. So let's just check on that. Let's put them off and no signal. Okay, so let's go to the NOT gates. Let's check the behavior of this one. Let me now put my pin. My pin number is now pin number 9 for the LED. So already I'm getting a signal, meaning that for this one, if both of the switches are off, I get a signal. My overall output is on. If I say A is on, I get an off. So if A is on, I get an overall off. Let's see, if B is on, I get an on. A is on, no signal. If B is on, I get a signal. If both are on, no signal. So both off, I have a signal. So this one is unique. If both the pins are off, the switches are off, I get a signal. If B is on and A is off, I get a signal. If A is on, then no signal. B is off, no signal. So A seems to be the one that's doing a lot here. If A is on, then there's no signal. If A is off, then there is a signal. B seems to be doing not to be doing much here. If B is on or off, I still get an on there. If both of them are on, then I get a signal. So A seems to be the one that's doing all the work here. Let's check the description on our truth table. So yes, everything is depends on the position of A. If A is 0, then I get a 1. If A is 1, then I get a 0. So this is all dependent on A. If A is 0, I get a 1. Yes, if A is 1, I get a 0. B is not doing anything in this gate. Let's move to the to the XOR gates. So I now have to turn my LED light to pin number 8. I already got a signal there. Let's check the truth table. It's saying here, if both are on, off, I get an off. If one is on, I get an on. If one is on, I get an on. If both are on, I get an off. So let's see. Both are off, I get an off. One is on, I get an on. One is on, I get an on. If both are on, I get an off. So that's it. This is the illustration that you need if you do not have the equipment, if you do not have the time to connect everything, if you do not have the right operational amplifiers. So with your Arduino training, you can do a lot. You can do experiments in many other experiments, oscillation, calculating your period. Your Arduino can simulate all those conditions, and you can teach even without equipment. So we are available to come and train you at a very affordable rate. You can contact me on the numbers that will be showing on your screen. We are available to come where you are to do the training. So I'll see you at your training, and I'll see you in the next video.